Hey math fans, we're on section 2.8.2. Let's get started. Today we're going to be talking about the transformation of a function graphically, more importantly, how it will shift vertically. And when it shifts vertically, the entire graph moves up. We're going to start calling that a translation. You might have heard that term before, where you can move a graph vertically, horizontally, but it doesn't change the shape of it. So we're still going to be using function notation, but as you can see, we're going to be introducing a new number here called k. And k is going to be the value of that vertical shift. If k is positive, the graph is going to be translated or shifted up k units. And if it's negative, it'll be translated down k units. Example 1, graph the following functions on the same set of axes. Now notice each of these functions has a different k value. Of course, the k value in the f of x function is 0, but notice they're all different values that are being either added or subtracted from that original 3x. As always, make a table. Take a look. F of x is equal to 3x. You get 0, 0, 1, 3, 2, 6, and 3, 9. But when I have 3x plus 1, instead of 0, 0, now I have 0, 1. Instead of 1, 3, I have 1, 4, because every time an x value goes in here, a 1's going to be added to it. Each of these is 1 greater than each of these. So what does that mean graphically? As you can see, the red graph is the one for f of x is equal to 3x, and the blue graph is for g of x. As you can see, the g of x graph has been shifted up 1. All of those points are 1 greater than what it originally was with f of x. Now it's time to see what happens with the other two functions that are added in. H of x is 3x plus 2. Now that's shifted up even 1 more. So you have the green, which is above the blue now by 1 unit. And then the final function was q of x, which is 3x minus 2. And notice how it falls 2 below, or it's shifted down 2 from the original red graph of f of x is equal to 3x. And so those are the 4 functions, as you can see, all being shifted vertically depending on what that k value is. Again, the official name of this transformation is called a translation. It's sliding or shifting the shape without rotating it or flipping it. So here's an example of a triangle that's being translated. Example 2, given the graph of f of x is equal to 2 to the x plus 1, let's graph g of x, which is equal to f of x, but we're subtracting 5 from it. So just like the other one, this is going to have another vertical shift. Let's see what it looks like. Here's the original graph. F of x is equal to 2 to the x plus 1. Now here in Desmos, I decided to put g of x is equal to f of x, because that's our starting point, is f of x. And the problem says, we're going to have a starting point of f of x. So notice it's the same graph, isn't it? But now let's change the value of k and see what happens. So now we have g of x is equal to f of x minus 5. Look what happened from the red graph, which is f of x. Now g of x has been shifted down 5 units. I chose a point in the original graph 2, 5. Now notice in the other graph of g of x, it is now, that point has been shifted down 5 units from 2, 5, and now it's all the way down at 2, 0. Example 3. The graphs of two functions f of x and g of x are shown. Write a rule for g of x in terms of f of x. Now, people always get confused on this problem because they don't know how to write or which order to write the rule in. And so when it says write a rule for g of x in this case, that's where you're going to start. G of x is equal to, so it says write a rule for g of x. We're going to write g of x is equal to some rule. Now it says in terms of f of x, which means that f of x is going to be in the second part of this equation. So g of x is equal to f of x, but now we got to start seeing, like in this graph, if this is g of x and this is f of x, we're starting at f of x. What's happening here? How are we getting to g of x, basically? If we start, this is our starting point, how are we getting, or what kind of shift is being made to get to g of x? Just by counting the number of units, you can see that it's 7 units. G of x is 7 units above f of x. So in other words, if I want to write a rule for g of x, I'm going to say that g of x is equal to my starting point of f of x plus 7 for our value of k. And that's going to do it for this section. We'll see you in class.